The last part we spoke about the integral of vector functions. And we say that the integration of the vector function is equal to the integration of the component of the vector function. For today, we are going to speak about the line integral. What do you mean by line integral? The line integral is an integral where the function to be integrated is evaluated along a curve or a path. We have a path, and we need to integrate some function moving over this curve. So it is just the integral where the function to be integrated is evaluated along a curve. And with the definition of the line integral, let's see this one. If we have C is a smooth curve, and or three space. Then the line integral of f with respect to s along C is given by integration along the curve C f of x, y, ds is equal to the limit sigma f of x k star k star delta ks, where the maximum delta is equal to 0 or goes to 0. So this is the formula for the integration of the line integral. We integrate a function f along or evaluated along a curve C with respect to s, where s is just the parametric equations of the curve. It's all given by the line integral or just the arc length. As we mentioned last time, the arc length of the curve is given by integration of the magnitude of the derivative of the vector function. Now, if we have two-dimensional function f of x, y, as we change x or we change y, with that delta x will be also changed. So for that we have partition. For one-dimensional case, if I have a function and to find the value of definite integral between a and b, this is a definite integral. Definite integral for f of x is given by integration from a to b f of x dx. This is with respect to x, which is equal to the limit f of x, say star delta x is equal to the limit where delta x goes to 0. Delta x is just the partition of the interval a and b. This is delta x. the difference between 2xi and xi plus 1. If we have two-dimensional case, f of x, y, so we will have two partitions, one with respect to x and one with respect to y, and to find that delta, either delta x or delta y, or just find the magnitude of the vector function, that will be delta s equal to magnitude of f square or f prime square plus d prime square. Now, if I have two-dimensional case, integration of f of x, y, b. Sometimes we need to differentiate this with respect to x, and sometimes we need to differentiate it with respect to y. So if it is with respect to x, I will find the limit of delta x goes to 0. F of x I y delta x. Some other cases I need to find with respect to y. dy is equal to the limit of sigma f of x yi delta y, where y or delta y goes to 0. But if we need to find it for both of them, with respect to x and y, we are using ds, this notation. So let's see now. If C is smoothly parameterized. Y vector function R of t is equal to x t I plus I of t j. For t to be in the interval between a and b. Then the line integral of the function f of xy ds, you have to be careful about this notation, with respect to s, the arc length, is given by integration f of xt, x of t, y of t, multiplied by magnitude r of t, the derivative of the vector function, dt. Now, since we are integrating with respect to t, I have to use the limit of t, that will be between a and b. So the integration of the function f of xy with respect to s along the curve c given by f of xt, y of t multiplied by the magnitude of the derivative of the vector function. Sometimes we are using one direct integration with respect to x or with respect to y. So with that, we want to find, we call it this time, I will use g because it will be one of the function. The integration C of the function d of x y dx. If I want to find the line integral with respect just one variable, dx, not ds, then this is equal to integration from a to b of the function g of f of t, g of t, multiplied by the derivative of f of t dt. Given that x equal to f of t and y equal to g of t. These are the parametric equations. If x equal to f of t and y equal to g of t, then the line integral of g of xy equal to d of f of t, g of t, multiplied by the derivative of the function f of t. If we want to find the line integral with respect to y, see, x, y, dy is equal to the integration from a to b, the function f of t, multiplied by the derivative of g of t dt. So the variable will indicate the form or formula for the line integral. This is the general form. Yes. Given by the integration a to b g of f of t of t. Now ds is given by the magnitude of the derivative. So this is the general form for the line integral, which was stated before as magnitude of r of t. For example, let's evaluate the integration one plus x y square ds, where c is given by the vector function t I plus t j, and t is between 0 and 1. When to integrate this one, you can see x equal f of t, and in this time it is t. This is the first one. This is x of t. Y equal to g of t, which is equal to 2t. And since we need to find the integration with respect to ds, ds will be the magnitude of r of t. Magnitude of derivative, we have to differentiate it. The derivative of t is equal to 1, the 1 square derivative of this one. 1 of t equal to 1, and this is derivative will give me 2 plus 2 squared, which is equal to square root of 5. So the integration will be 1 plus x is equal to t, y equal to 2t, multiplied by ds. ds equal to square root of 5 t. And since we use this notation, I have to write the limit for t, but that will be from 0 to 1. So we replace x by t, we replace y by t, or 2t, this 2t squared, because I have my function is y squared. This is 2t squared. This will give me, I will take square root of 5 outside, integration from 0 to 1 of 1 plus 4t to the power 3 dt. Which is equal to square root of 5 multiplied by, integrate this one will give me t, 4t to the power 3 will be t to the power 4. From 0 to 1. That will be square root of 5. Now evaluate, replace t by 1, I will have 1 plus 1 minus 0. The answer is 2 square root of 5. So this is the idea of the line integral. Let's take another one. Number 2. Let's evaluate. The function y dx plus x dy, an integral on the given curve c between the point 0, 0 and 1, 1, where c given by the equation y equal to x. Y equal to x. Okay. I have this curve. C is equal to y equal to x. I need to find the integration from 0, 0 to 1, 1 along this curve. This is y equal to x. So we are evaluating the function, this function, which is yx dx along this curve or this path. Now I have y equal to x. So what we need is to write the curve C using the parametric equations. Write the curve C. Using parametric equation. Or say define it, right? Define the curve C using the parametric equation. So say that x equal to t. Since y equal to x, this means that also y equal to t. This is one variable. So we just write or define the curve C using the parametric equation x equal to t and y equal to t. From this, it is very clear that dx equal to 1 and dy also equal to 1. And t will be from 0 to 1. T equal to 0, x equal to 0, t equal to 1, x equal to 1, and also y equal to 1. So the integration now x or y dx plus x dy. The curve C is equal to integration y is equal to t, so this is t multiplied by dx is 1 dt. I can say 1 dt plus x equal to t multiplied by 1, all of these dt. And the limit for the variable t from 0 to 1, which is equal to 0 to 1 of 2 t dt, which is equal to t square from 0 to 1. That will give me 1. So the value of the line integral along the curve y equal to x is equal to 1. Now let's change the curve. So with that, I want to find it with y equal to x squared. Given by y equal to x squared. This is a parabola. 0 to 0, and let's say 1, 1. This is a point. 1, 1. Up. This is 1, 1. So 0, 0, and 1, 1. Let's find the parametric equation. The parametric equation means we need to write the vector function for the curve r of t. So I need to find the parametric equation for this. So let x, usually we are choosing x to be t. And then we can find y. That y will be t squared from this relation. Y equal to x squared. So if x equal to t, then y equal to t squared. And dx will be 1 dt. And dy will be 2 t dt. So the integration, which is given by c of the function y dx plus x dy is equal to y is given by t square. Dx is equal to dt plus x is equal to t. dy is given by 2t dt. Now for the limit. I have the point from 0, 0 to 1, 1. If x equal to 0, this will give me t equal to 0. If x equal to 1, then t equal to 1. Or I can use the y, it is the same. If y equal to 0, then it will be 0 for t, and if y equal to 1, t is equal to 1 or minus 1, but we don't have that minus 1 for t this time. So it is from 0 to 1. So the limit for t is from 0 to 1. This can be written as 0 to 1 of t squared plus 2t squared dt, which is equal to 0 to 1 of 3t squared. And that will give me t to power 3 from 0 to 1, which is equal to, again, equal to 1. So along the curve y equal to x, the value of the integration is equal to 1. Third case, or third part of C. Suppose that C consists of the line segment. Zero, zero, 2, 0, 1, and from 1, 0 to 1, 1. Let's see. Say that the line segment or the curve C is moving from 0, 0 to 0, 1. This is 0, 0, and this is 0, 1. So I have, this is first segment. I will call it C1. And from 1, 0 to 1, 1. So this should be 0, 1. 0, 1 to 1, 1. This is C2. So we are moving from 0, 0 to 0, 1, and from 0, 1 to 1, 1. I have two line segments. And I need to find the integration for that function along the curve. This is the curve C consists of C1 and C2. So the line integral for the function in this case, x dx plus y dy is equal to C1 plus the integration along the second curve C2. So it is x dx plus y dy. This is for the C1. C2, it is again x dx plus y d1, or not plus, sorry, y dx and x d1. The question was, I have y dx plus x dy and also y dx and x dy. So the idea is to find the integration along the two curves, C1 and C2. For each curve, now I need to find the parametric equation for C1. C1, what is changing is the y, not x. You can see in this one, x equal to 0. This fixed. Moving from 0, 0 to 0, 1, x equal to 0. And y? Y is changing. So I can let y equal to t. But it is moving from 0 to 1. This is C1. C2. X is changing from 0 to 1. So I will say x equal to t. See, this is C2. X is moving from 0, 0 to 1, 1. Or from 0, 1 to 1, 1 means x is changing from 0 to 1. So I say let x equal to t. But on this curve, y is fixed. Y is constant, it's not changing. Y equal to 1. And again also, t is between 0 and 1. So these are the parametric equations for C1 and C2. Let me use these to evaluate the integration. This is equal to, so C1, y equal to t multiplied by 0 because x equal to 0, so dx equal to 0. So the first one will be 0 plus x is 0 multiplied by 1 dt, 0 to 1. This is C1. Plus C2, now we're asking about C2. Equal the integration between 0 and 1, this is t. Y equal to 1. Dx equal to 1 dt. See this one. So replace y by 1 and dx by dt. It will be 1 dt plus x equal to t, but dy equal to 0. So this is t multiplied by 0. This will give me, the first one is 0 plus 0 to 1 d, which is equal to t between 0 and 1. That will give me 1. So the line integral along the curve or the two segments 0, 0 to 0, 1, and from 0, 1 to 1, 1 will give me 1. The idea is to construct the two curves, C1, C2, find the parametric equation for each one, then evaluate the integration.